Well, a warm welcome to everyone joining. Thank you for being here. Get yourself ready with a notebook, a pencil, or a pen. Anything you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we're going to continue with our quick SAT problems. This is a problem from a SAT style test. And it covers functions and transformations of functions. It was kind of hard to categorize this problem because this isn't like a core concept in math explicitly that you would learn, like in a math class. But it does come from concepts that you would have learned about transformations of functions. And it's actually a really simple problem, but it looks a little bit tricky. We see a graph. I wonder if that graph's going to be heavily involved. So go ahead and read the problem. Give yourself about a minute and a half or two if you need to try to solve this. Although this is one of those problems where when you see how it's done, when you can see how to do it, it only takes about 45 seconds maximum. If you can't figure out how to start, it's generally just not going to be solvable. It's not any amount of time that it's going to take. You really just have to see this one trick. So go ahead and pause the video. Give yourself about a minute and a half or so. And then when you're ready, you can come back and see how I did it here. There are some multiple choice answers that I didn't want to provide there because I'd like you to learn how to actually solve the problem without looking at any answer choices. And then, you can check the answer choices to confirm that what you did is even an option. All right, without further ado, let's get started here. So we have this graph. It says the figure above shows part of the graph of function f. And it gives us this very important relationship. It tells us that f of x plus 6 equals f of x for all values of x. And the task is to find the value of f23. So obviously we're not going to be able to look at this graph and see all the way down along the x-axis. What do we get when x is 23? We can't tell. But we need to use this relationship here. So this means that, for example, f of 23 plus 6 is going to be the same thing as f of 23. So if I want to know what f of 23 is, I would be able to find it by going to f of 29. Unfortunately, that takes me further down the x-axis. I don't want to go further down the x-axis. So let's think about this sort of going backwards. Well, that means that f of 23 is also equal to f of something plus 6. Well, of course, 23 is 17 plus 6. So that means that this is the same as f of 17 plus 6, which is the same as f of 17. And now we have an idea that we're basically going to scoot back 6 spaces and we'll have the same exact y value. So that means this is also equal to 11 plus 6. 17 is just 11 plus 6, and that's equal to f11. But f11 is the same as f of 5 plus 6, because 5 plus 6 is 11, which is equivalent to f of 5. So really we have this string of equalities which connects us from f of 23 all the way to f of 5. And if you notice, we do have enough information on the graph to figure out what f of 5 is. This is going to be 1, 2, 3, 4. So we can say that f of 5 equals 4. F of 11 also equals 4. And we get this interesting repetition. F of 17 equals 4. And of course, f of 23 must also equal 4. And if you had the answer choices available to you, the correct option would be answer choice D, 4. Okay, so what they've done here is they've given us a transformation of a function by saying f of x plus 6, but what they've also done is they've kind of introduced this periodic property. This is a property of a periodic function because the function values repeat after adding a certain amount, a defined amount known as the, you guessed it, the period. Now this might not mean something to students who haven't studied trigonometric functions like sine, cosine, or tangent, but this is actually very similar to what's going on with sine, cosine, or tangent. You might remember that if we have a function like sine or cosine, I'll just use cosine as an example. Cosine repeats, so g of x plus 2 pi, for example, equals g of x. In fact, I could say g of x plus 2 pi k, or 2 pi n, where n is just some whole number, some integer. This is true. And so for the function that we have here, we could say that f of x plus 6k equals f of x. That basically just means that if we were to add any multiples of 6 to the input, we get the exact same output. And that is the quality of a periodic function. So you don't need to use that property or definition to help you out with this problem. You don't need to know that it's called a periodic function or that this is a periodic property. But if you notice that there is that pattern there, you can maybe relate it to something like a sine or cosine function. In any event, it's a very quick problem if you know what to do. If you know to just sort of scoot back by 6 at a time, you can scoot back 6 spaces 3 times and end up at 5, which is represented on the graph. So that's how we're able to now use the graph to answer the question. All right, I think that's enough blab out of me. If you guys like these shorter style SAT prep videos, feel free to leave a like, share this with someone you think might find it valuable or helpful. I'll see you guys next time.